This video will review factoring polynomials. Now we're assuming that you've had some practice with this and some work with factoring different types of polynomials. So this is just going to be kind of an overview of different examples. Let's start with two terms. If you have a two-term polynomial, or any polynomial as far as that goes, the first thing you always want to do is factor out the greatest common factor. If there is one, now example A, 4x squared minus 36, 4 is a common factor to both terms. So the first thing you do is factor out that 4, divide both terms by 4, and that leaves 4 times the quantity x squared minus 9. Now x squared minus 9 is factorable. It's called the difference of two squares. That's where the first term is something squared, which is x times x. The second term is something squared, which is 3 times 3, obviously, with a minus in between. So it's the difference subtraction of two squares. And that will always factor into plus and minus, x plus 3, x minus 3. Done. Example B is not the difference of two squares. Now that's the difference of two cubes, which is a special case. X cubed is x times x times x. 8 is 2 times 2 times 2. Thus, both terms are cubes. Now the pattern for the difference of two cubes, let me give you the generic pattern. X cubed minus y cubed will factor into x minus y times x squared plus xy plus y squared. Now if it were x cubed plus y cubed, that's called the sum of two cubes. That also factors very similarly, except the signs are different. It goes x plus y times x squared minus xy plus y squared. So we're going to use those two patterns in order to factor this. Well, since this is a minus, we're going to use the first pattern. So you take the cube root of the first, which is x, the cube root of the second term, which is 2. So it's x minus 2, and then you square the first term, which is x squared, plus the product of the two terms, 2 times x, and then you square the second term. And you are done. Now once you do that, you'll never have to continue factoring it. People will look at that second trinomial, x squared plus 2x plus 4, and think, wait a minute, I need to factor that further. No, you'll never have to in those problems. Let's do another example, which is a little tougher. Example number 2 is that the difference of two cubes. Well, 27 is 3 times 3 times 3, so it's a cubed. X to the 6 is x squared times x squared times x squared. 8, 2 times 2 times 2, and a is a times a times a. So let me write that 3x squared cubed, and 8a squared is 2a cubed. So it'll factor using the pattern again. 3x squared minus 2a is the binomial. In the trinomial, you square the first term, which is 9x to the 4th. You do the product of the two terms, which is going to give you plus 6ax squared, and then you square the second term of the binomial, which gives you 4a squared. And again, you're done. That's it. So these two patterns up here, you just have to know in order to factor the difference or sum of two cubes. One of the tougher ones to remember. Let's go down to part C, which is three terms. Well, we're going to start the same way as every other problem, and that is GCF. So does each term have a common factor? And the answer is yes. They all have a 3, and they all have an x, which can be divided or factored out. So I take out the 3 and the x. In the first term, that would leave x squared. The second term, that would leave 2x. And the third term, that would leave 24. Alright, now we're going to focus on x squared minus 2x minus 24. And as I said earlier, that we assume that you've done lots of those problems. So reverse FOIL, you know it's going to factor into two binomials. Of course, x times x gives you the x squared. And now we have to figure out what goes there and there. Well, the product of those two numbers has to equal negative 24. Since it's negative, the sign combination will have to be plus and minus, because a positive times a negative gives you negative 24. And then the sum of those two numbers in the yellow will have to add up to negative 2x. Well, you kind of think of the factors of 24, 8 and 3, 2 and 12, and 6 and 4 is the right combination because 6 and 4, their difference is 2. So to get the signs right, we go plus 4 and then minus 6, because if we add these two together, 4 minus 6 is negative 2, which gives us the middle term. Of course, as I said, you should have done hundreds of those problems until you're just sick of them. But anyway, let's move on to 4-term factoring, part D. If you see 4 terms, the first thing you always want to do is try grouping them, the first two and the second two terms. Then in each pair, in each grouping, you take out the greatest common factor. So 9x cubed minus 72x squared have a common factor of 9 and x squared. So we take that out, and that would leave x minus 8. The second pair, and notice I grouped it so that the sign of the third term goes inside the parentheses. And we want to take out a negative 4, and that would leave x minus 8. Notice how that sign changes. And the reason we have to take out a negative 4 because the object is to get the same binomial. And if we had not taken out a negative 4, the signs would not be the same. Now that common binomial that's in both the terms, we'll take that and kind of move it out front. I'm going to strike it out, and then what's left is 9x squared minus 4. Now never be tempted to quit too early. Always take a look at where you are at this point, and you'll notice hopefully that the second binomial is the difference of two squares. So now that factors. That's what makes factoring so much fun. It just keeps going and going and going. So 3x squared minus 4, 3x plus 2, 3x minus 2. And now if you take a look at everything, all factors are factored all away, and that one is done. Example E, x to the fourth minus y to the fourth. Two terms again. The first thing you always want to think is that the difference of two squares is that the difference of two cubes. Well, x to the fourth is a square. It's x squared times x squared, and y to the fourth is y to the squared times y squared. So this will factor into x squared plus y squared, x squared minus y squared. And again, don't quit too early, because if you take a look at the second one, the second binomial, yes, difference of two squares again, x plus 2, x minus 2. Now x squared plus y squared is the sum of two squares, but that does not factor. It's the difference of two squares that factors, so we'll just rewrite that, x squared plus y squared, and the final answer is circled. Let's take a look at a couple more examples. Let's go with 2x cubed plus 4x squared plus 4x plus 8. Now remember the golden rule of factoring, always look for the GCF first. And yes, there is one, it's a big 2, so we take 2 out of everything. And just get in the habit of looking for that greatest common factor. It's going to make your life a little easier to do that. So I divided each term by 2. And now I have a 4-term polynomial, so just bring that 2 down and forget about it, and we'll group 2 and 2. So x cubed plus 2x squared in the first group, and plus 2x plus 4 in the second group. Now out of those two groups, again, kind of keep that 2 out front so it doesn't get in the way. We'll focus on those two binomials. The first group, you can take out an x squared, and that would leave x plus 2. And in the second group, you can take out a 2, and that would leave x plus 2. And that's the whole idea, is try to get the same thing there and there. Okay, now at this point, I'm going to take that x plus 2 out front. Again, just kind of bring that 2 down, don't let it bother you, it's just sitting out there temporarily. And if we factor the x plus 2 out of both of those terms, that would leave x squared plus 2 as the remaining factor, and that is done because everything's factored and that 2 just comes down. It's one of the factors, so it's 2 times the quantity x plus 2 times the quantity x squared plus 2. Final answer. Let's take a look at one more. It's a little bit different. Let's go x to the 6. We'll keep it fairly simple. Minus y. Let's just go y to the 6th. Alright, you may be tempted to think, well, that's the difference of two squares. Well, it is actually, because it's x cubed. It's the square root of x to the 6 and y cubed. But if it's also the difference of two cubes, which it is, I would recommend doing that first. So let me get that pattern up here again. So x cubed minus y cubed factors into x minus y times x squared plus xy plus y squared. Now we have to figure out what's being cubed for each term. Well, the first term is x squared times x squared times x squared, and the second term is y squared times y squared times y squared. So I'm just going to rewrite it like that, and so we can apply the pattern. So this will factor into x squared minus y squared. You take the first and the second, and then focusing on just this, let me highlight that, focusing just on this binomial to get the rest of it, you square the first term, so that's x to the 4th. You write down the product of those two terms in yellow, and then you square the second term of the binomial, which is y to the 4th, and that's plus. Okay? Now I said earlier that the second part will never factor further, but in this case the first one factors. That what's in the yellow is the difference of two squares, so it goes x plus y, x minus y, times what I underlined, x to the 4th plus x squared y squared plus y to the 4th. So that one's a little trickier. It's just with two terms, sometimes they'll factor further if it's a square and a cube both, so you got to watch out for that. But I recommend doing the difference of two cubes first. Some people say, well, isn't the difference of two squares, wouldn't that come first? Well, you can do it that way, but it's a little tougher. I prefer this method. Usually it's more efficient. Alright, that's just an overview of several different types of polynomial factoring which you should know, or what you need to know in order to advance further.